So very good afternoon and warm welcome to everyone. And it gives me immense pleasure to welcome Dr. B.S.K.V. Harish, Assistant Professor in Department of Electrical Engineering, Netaji Subhas University of Technology, Dwarka, New Delhi, to the Faculty Development Program on Smart Building Design and ECT for NetZero. Dr. Harish will be delivering a session on the crucial topic that is control of building energy control systems, and focusing on the how smart building technology and intelligent control strategy can be significantly improved in building performance, energy performance, and occupant comfort. His expertise in energy systems, machine learning application in building control, and occupant centric approaches will certainly offer valuable insight to all the participants. So we honor to have with us Dr. Harish. And before that, I call Subham sir to briefly introduce the expert to the participants. Over to Subham.
Thank you so much, Ravi sir, and good afternoon, everyone. It is a pleasure to welcome our next expert speaker, Dr. B.S.K.V. Harish, Assistant Professor in the Department of Electrical Engineering at Netaji Subhas, University of Technology, Dwarka, New Delhi. He holds a PhD from IIT Roorkee and a gold medal in ME Power Engineering from Jadavpur University, both supported by MHRD fellowships. He also completed a postdoctoral fellowship at the Terry School of Advanced Studies, where he worked on a Netherlands funded project focusing on smart grid solutions for rural India. His research spans smart energy system, building automation, and control strategies for energy optimization, with over 1,600 citations to his credit. He has received Best Paper Award, multiple international travel grants, and was twice nominated for the Young Energy Research Award at the World Sustainable Energy Days in Austria. Today, Dr. Harish will speak on robust control of building energy control systems, offering insight into how smart technologies and control algorithms can enhance energy performance while maintaining user comfort. Please join me in warm welcoming Dr. Harish, and over to you, sir.
Thank you so much, sir, for nicely introduce the expert to the participants. And once again, thank you, Harish sir. And I look forward for an engaging and enlightening session. Over to you, Harish sir.
Thank you, Professor Meena sir. Thank you, Professor Ravi sir, for the opportunity. Shall I go ahead and share my screen, sir?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
What I will do is I will share complete screen here. Is my complete screen visible, sir?
Yes, sir, your screen is visible. Now it's in the presentation mode also.
Okay. 1 minute. So there. Right. Very good afternoon, very good morning to all of you. And I sincerely thank Professor Meena sir and Professor Ravi sir for giving me this opportunity. This, I was told, will be a hands-on session. So my focus will be linking theory with practice. Okay. Because it's an online course, so I will give you overview of how I used a particular software. Actually, we can do the co-simulation of other softwares as well, but that will be a 1 day or a 2 day long workshop. So for this, what I have done is two things, as Professor Meena sir was saying, that one is robust control, second is the building energy control systems. And third thing that I mentioned very specifically in the previous presentation a day before yesterday also, that with the booming sector of smart cities and ICT technologies, and with the booming of digitalization, it will be imperative that the distribution company will have a little bit of control over our energy systems as well. One of the energy systems, two of the energy systems that we discussed in the previous lecture was the lighting systems and the air conditioner systems. Today, what I will show you is in MATLAB how we can achieve this, or in a way address the knowledge gaps that we were discussing in detail in the previous lecture. So it will be a MATLAB based exercise, this particular hands-on. Second thing is that let me put this, because I was told by Professor Ravi sir that there are large number of architectural background, energy background researchers, scholars and faculty members and industry people. So let me put forth this one point, that robust control or robust controller is a process or an approach of designing a controller. It does not necessarily mean that you go to a market and ask for a robust controller. That means, for example, all of us have majorly studied and heard about PI control, right? So if you go into the market and if you are developing a controller, you can have a PI controller and you can have a robust PI controller. Robust controller does not mean that it is a different controller. रोबस्ट कंट्रोलर कोई अलग तरीके का हार्डवेयर आर्किटेक्चर नहीं है कि एक है पीआई कंट्रोलर और एक है रोबस्ट कंट्रोलर, नहीं. A PI controller itself through enhanced performance becomes a robust control. So when I say robust control, it means that a particular controller has an enhanced performance. And now what is that enhanced performance? Robustness means, as the word signifies or the word represents, means that if I design a controller, for example, traditionally or conventionally, I prepare a model in whatever software I want to. For that particular model, I give a set of inputs and I'll get a set of outputs. Now, if I want the output as desired and the output which is coming through the mechanism of the system is not desirable to the user or the consumer, so I will not change the model because it will not replicate the existing system. Okay, what I will do with the model, I will design a controller, and I know that if I change the inputs of the model, proportionally the output of the model will be changed. So input of the model will be an output of a controller. So I will have a controller. The controller will give me the output. That particular output, but that particular control signals will be given to the model. Then the model's output will be changed. Now, this is traditionally how we design a control system. Okay. Now, robustness means that this activity of having a controller output connected to the model's input and the model output is as we want, as the consumer wants. Okay. Robustness means that this complete cycle or process or the performance will not change if there are some external disturbances on the model or on the controller. There are two types of disturbances. Let us understand mathematically what disturbances or perturbations, what I meant to say. It can be large amplitude, small time disturbances. That means a signal whose, if I plot the signal with amplitude and the time axis, the time axis is very small, the time of sampling is very small, and there is a large magnitude. Or small disturbances for a larger period of time. So if these disturbances are in the model and it is not in the hands of the modeler, those are the disturbances that will happen. For example, I'll just give you an example only for your understanding, digressing from this topic. You want to develop a control system for your two-wheeler. टू-व्हीलर डिजाइन किया गया है कि रोड है, रोड के ऊपर चलेगी, but actually the road may have speed breaker bumps or the road is not a proper constructed road and it has large number of humps and lumps. Now the manufacturer has to take into considerations what are the realistic conditions and design a robust controller so that the vehicle and the passenger of the vehicle both are safe and are having comfort, even if the road is not smooth. Okay, that is what robustness means, right? I hope I have made this clear. So we will start with the robust control for buildings to grid integration. Let us another request with all of you, as wrote in the hello. Am I audible?
Yes, sir.
Okay. So
Yes,
as we discussed, thank you, sir. As we discussed in previous lecture also, that it is important for us to understand why we require buildings to grid integration. So what is happening is we have understood that a large number of buildings are coming up, but they are not a 2-floor or 4-floor building. They are the skyscraper type of buildings, or I will not say skyscrapers, sorry, but high-rise buildings. So and if you say that for every floor there are 4 houses, every house has a 2 BHK property, at least one air conditioner will be installed there, and there will be a large number of lighting processes also. And the studies have also shown that lighting systems and HVAC air conditioning systems or air conditioning services are one of the major services which consume energy in terms of residential or commercial buildings. Now, what happens is, with the advent of small scale on-site renewable energy systems, such as majorly solar PV systems, building integrated photovoltaic systems, electric vehicle charging stations getting connected in our households or societies, which has more than 100 households. And if you have a high-rise building, the concept of small wind energy systems coming into the picture, battery energy storage coming into the picture, depending upon your architecture and the site you are in, thermal energy storage coming into the picture. So there is a flexibility of small scale electricity generation sources being installed in the load side. Okay. Now, at such a condition, the operator of the grid, that is the distribution company, that is the company or utility which is providing you the electricity bill, has a very peculiar challenge right now, that the architecture being designed for a one-way flow of energy or a one-way flow of electricity from their substation or their transformer to your home. Now, 2 things are happening. The consumption is being reduced. So the electricity is a concurrent subject in India. So the state and center both have the say in it. And the distribution for residential consumers majorly becoming a state subject where private partners also can come. They always do a day-ahead marketing, and through electricity markets in India, we have IEX and PXIL, that is India Energy Exchange Limited and Power Exchange of India Limited, जहाँ पे trading होती है बिजली की, because electricity is an economic commodity also. Now they trade, now they are prepared that the next day in June, there will be a good amount of electricity consumption, and they have bought that electricity. But because in June you have a very good solar profile, you may be using very less energy from the grid and more relied upon the solar PV system on your rooftop. Or it can be a diesel generator backup set, which may become cheaper, and you are dependent upon it. Or in the future, you have connected the electric vehicle charging stations, and June being summer holiday time and work from home coming into the picture, maybe the electric vehicle is not flying at all, and there are large number of battery that is being stored and at a very good SOC, and you want to use it, right? Now, how to address this flexibility? So one of the challenges is the buildings to grid integration system. What is happening is, with the advent of inverter air conditioner systems, the distribution company can make use of the change in the thermostat supply. For example, I have set the air conditioner at 16. So the air conditioner is using a large amount of load. Now the distribution company, if I don't have a remote and I am using it through my telephone, using it through my mobile phone, maybe distribution company can provide me with an app, and that app gives me the option that do you give permission that your air conditioner through the mobile phone can be controlled by the distribution company. Now the distribution company, what it will do, if the load is very, very high, demand is very, very high, and the electricity is very, very costly at that period of time, for the distribution company can control that particular 16 degrees Celsius of my thermostat setting. What it will do, it will come to 24, 26 or 28, right? In a similar fashion, the other way around also. Of course, 16 degrees Celsius does not make any sense. And ultimately, the decision making will be with the consumer only. If I am not happy, I am say I will pay you more, but provide me 16 degrees Celsius. That is building to grid integration. Majorly, how it happens is that whenever there is a mismatch between the supply coming from the distribution company and the demand that we are providing to the grid, whenever there is a mismatch of voltage and frequency. right? If there is a small mismatch with voltage and frequency, it's okay. That is within the frequency band limit. But if it is a large mismatch, then there is a problem with the load also. It will hamper the load also, the performance, and it will hamper the huge costly generators of the power plant also. Because what happens is, I'll just give you a brief introduction of an electrical power system. What usually happens is generation, long distance transmission through large and long distance transmission lines, then distribution, and then consumption. All this are connected through a network of electricity. All this, if they are connected together, you can view them as a very large synchronous generator being operated. That means if some bad thing happens to the load and our switchgear and protection devices does not trip that particular load, then it will hamper up till the transmission system also. इसलिए blackout और brownout होते हैं ज़्यादातर, right? So that is why it is necessary that all the, and in India we are one nation, one grid, one frequency now. There were 5 regional grids: north, east, west, south, northeast region. Then these 3, the top north, west, and northeast and eastern grid got connected. Then the 4 got connected. Then it got connected with the southern grid through that Nagpur link, right? So now we are one nation, one grid, one frequency. You can go through the site of NLDC, National Load Dispatch Center, then NRLDC, Northern Regional Load Dispatch Center, SRLDC, आप लोगों का NIT Patna comes under ERLDC, Eastern Region Load Dispatch Center. Then आप अपने स्टेट की वेबसाइट पे जा सकते हो और अभी इस वक्त you can see and record what is the grid voltage and base voltage and what is the grid frequency, right? So you can see that, and it is continuously changing, just like the stock market changes continuously when it is open. Similarly, a grid changes continuously throughout the day, 24/7, 365 days, right? What buildings to grid integration can do is, whenever the supply is more, it will try to increase the supply, maybe through energy storage devices. And whenever the supply is less and the demand is more, it will suppress the demand also. For a few seconds, because we are getting 50 hertz of frequency. इसका मतलब क्या हुआ? That 20 millisecond में एक cycle खत्म हो जा रहा है. So if I can provide a good frequency support for few seconds also, that we call it as transient support, it will be enough, right? So a thermostatically controlled load can make use of their thermal inertia. And what is TCL or thermostatically controlled load? Any appliance whose operation can be controlled through a thermostat. It can be a smart refrigerator, a smart water heater, a smart air heater, building air heater, and it can be an air conditioner. A couple of years back, Terry came up with a interesting independent report saying that of the roughly 290 million households, fewer than around 20 million have ACs, and this is increasing, right? So we can make use of this and combine the buildings and the grid. This comes under the subset of smart grid. See, building energy systems, this we discussed in previous class also, are those systems or processes or equipment or machinery which are responsible for the energy usage across the buildings, right? And if we talk about the smart grid, again, I really want to repeat here, is in previous lecture also I told you that I will be giving you the definition not coming from Google, Wikipedia, or some private newspaper or news channel, but the standardized definitions. And this will help you in developing your research papers also and research proposals also, right? Now, smart grid, according to the National Smart Grid Mission, which is governed by the Ministry of Power, Government of India, it states that a smart grid is an electrical power grid that has the capability of automation integrated with information communication technology systems, which can monitor and control the real power flow from the generation up till the end use level. This is very much important. Up till the end use level in order to match the generation and demand. यही तो था building to grid integration का concept, right? Now you will ask me, sir, is Indian power grid a smart grid? No, because now we are not monitoring and controlling. We are not yet achieved the monitoring up till end use level. जिस कंपनी से मेरे घर का बिल आता है, उसका जुरिस्डिक्शन मेरे मीटर तक है। मीटर के बाद मैं 10 एसी लगाऊं, 12 एसी लगाऊं, कैसे चला रहा हूँ, रेफ्रिजरेटर कैसे चला रहा हूँ, इंडक्शन स्टव इस्तेमाल कर रहा हूँ कि गैस पाइपलाइन इस्तेमाल कर रहा हूँ, वो मॉनिटर नहीं कर पा रहा है, उनको नहीं पता, राइट? So there is no load intrusive monitoring, right? So right now we are not at a smart grid position. First we have to reach at a position where we can monitor it. Again, monitor does not necessarily mean that there should be a wire and that wire should be connected. No, it can be monitored through phone, right? And then maybe it can be controlled through mode. Of course, all of us who are attending this FDP, we all are researchers, so we know that technologically we have to be extravagant. That not only we are working, we are not only consultants that we work for the current industry's problem, but we have to envision what will be the future industry's problem and come up with the solutions as well, right? So buildings to grid integration can be one that particular solution. This I told you what is energy efficient building or a zero energy building. Again, this is the technical definition that has been taken from the US Department of Energy, which majorly we also follow. Another thing that is important to understand is the difference between an energy efficient building and a green building. Green building majorly not only talks about energy, but also talks about the waste, materials, the water usage, environment as a whole. Energy efficiency majorly talks only about energy, two forms of major energies that are thermal energy and electrical energy. Okay. This is a concept where Grid Optimal Buildings Initiative was taken up by the new building institutes, where they talk about how the buildings, that can be an office building, it can be a residential building, it can be a commercial building also, but it can make the grid greener through buildings to grid integration, because we are now trying to achieve smart buildings, smart cities with complete decarbonization or green energy usage. So grid interactive building energy system is one way where we can use it. And what is the process of developing it? Again, the process which I am outlining and you're seeing on your screen is not a universal process. It is a process which I have employed in my research. One is that we start with the building energy modeling simulation. Then we do the multi-objective optimization of improving the occupancy comfort and minimizing the energy. Then we go to how we can now make a model to interact the building energy model and the grid model. So there will be a model of the grid, there will be a model of the building energy system, and then there will be an interface between these two. Majorly, the interface will be through a power electronic interface and a smart meter. Then how do you do the hardware implementation, evaluation, and do the FDD? FDD stands for fault detection and diagnosis. I have no results for step 4 because I am still working on research proposals. So hardware पे अभी हमने काम नहीं किया है. So these were the parameters that we discussed in previous lecture. I will not repeat them, just to show them, because I think that day before yesterday, after also you had many classes. So just to have a completeness, I am showing you these slides. I'll show you, we will look at this paper also, the paper that I am telling you. Let me go ahead and show you this paper. Yeah. Can anybody confirm if the PDF is visible?
Yes, sir.
Okay. So this was my PhD completion work, where we worked on the reduced order modeling and parameter identification of a building energy system through an optimization routine. What we did was, we first, as I told you, we first identified the parameters which are needed to be estimated in the building energy modeling, right? That is the table. And then we worked with the building energy system modeling, that is the complete HVAC system modeling, each and everything. So this is the significant parameters that I told you. Then I told you that we work on dynamic equations. I told you कम time sample के लिए हम काम करने की कोशिश कर रहे हैं. So for that particular time sample, it is dynamic in nature, right? So you always have an ordinary differential equation. So these ordinary differential equations are modeled in terms of linear algebra. Linear algebra, what does it do? Every non-linear equations can be represented linearly. So it becomes easy to analyze them. So for particular building energy model, the weather data, this is where I have used the Energy Plus library. So this weather data and everything, I can use it. I made it a CSV or an Excel file and then developed the building energy model in MATLAB and then used it for controlling this energy usage. This is the occupant-centric control. So you require the occupancy behavior model. Of course, as I told you, we didn't have the funds to work on hardware. So you always try with the assumptions part. So we started with the assumptions part that it was a single dimensional because majorly we were concerned about how we can make use of a robust control system. This I have improved upon this. This is nothing but we are trying to work upon for what purpose we can use this reduced order modeling, that is 3R 2C modeling for a particular building space. I told you that we are geometrically sitting inside a cuboid only. So उस तरीके से we have used it. This again the HVAC systems that we have used. These are the simulation parameters. All of these are available here in the paper as well. यहाँ पर रुकते हैं. I'll just show you how we have achieved this in MATLAB. Yeah. Everything which you saw in this paper okay. All these equations which you are seeing, this is very basic, class 11, 12, what do you call it as energy balance equations. Simple, right? All these energy balance equations, I made use of this Simulink block sets. Simulink is, sir, were there any hands-on sessions on MATLAB or should I give a brief introduction on MATLAB for the participants? I don't want to repeat myself.
Yes, sir, you can give a small introduction about MATLAB.
Achha,
We didn't
okay.
have any specific session on MATLAB yet.
Okay. See, MATLAB is a software which stands for Matrix Laboratory. It is majorly a computer programming language software, but it has a Simulink aspect to it where you can have a user interface blocks for your particular model, right? So usually you can command anything in MATLAB, and whenever you write anything which MATLAB does not understand, it will say that it is an unrecognized function or a variable. That means you have to write according to the syntax. And it is a calculator also. So if you write 5 plus 2 is equal to 7, you will get all these things. But if I do any wrong maths, for example, this is also writing like this. For example, this is MATLAB. So it will say that this is invalid expression. So it will not give me unrecognized function or a syntax error, but it will give me an error for improper mathematical or algebraic expression. Okay. Now, this is the basic of MATLAB. Now, MATLAB works on line by line command. So it becomes very difficult to code in the command window. So what we do is we make use of an editor. So a different window has opened, just like a text box. Here we can write whatever codes we want to write, save it as a code, and then run it. Okay, rather than using directly in the command window. There is one concept which is called as live script. So as I can, in this live script, in this script, you have to write only commands. You can't do a large amount of discussion. Live script, I can make use as a report, as a running report, right? It will not execute. The MATLAB will see this as a text and not as a code. This I can do using live script. Second most important thing of live script is, for a particular code written, I can immediately see its output. So live troubleshooting. Code लिख रहा हूँ, गलत हो गया, what happens is, usually what we face through MATLAB is we write, or those who are doing programming or have done programming, we write thousands of code, then run it, then an error comes, and it becomes very difficult to troubleshoot and identify where the error is. Here, I can write a set of codes and I can get a live result. So in this live result, I can see if my error is coming or not. That is your live script. Chalo. So we'll go back to those paper and we'll try to model this. Okay. So this is the model that I have developed. Credit to Professor C.P. Underwood of Newcastle University. I was referring his paper, and he was kind enough to provide me with few, literature, very important literature, which was not published, but was with him. So every time I give this credit to Professor C.P. Underwood also. He has an excellent book on modeling and simulation of building energy systems. I am opening a Simulink model so that I will show you how we developed this particular building energy system model. And then I'll show you what robustness means. How robustness means. And as I told you in the previous lecture also, we work on, for controllers, we design on the continuous time controllers, we design on Laplace transform. Discrete time or digital controllers, majorly we define on Z transforms. This is a concept of signals and systems. So I told you, and let me go back again to the PPT so that it becomes easy for you to understand. This is where we were working on. Okay? Geometrically, 4 walls, 2 windows. Come back here. External wall, partition wall, floor, ceiling, and ventilation aspect. 2 windows and building energy system. So for every, if I go, you will get a, this is a state space equation. What is the state space equation? Here, this equation. Equation number 5. State space equation. This is called as you can see here in the paper also we have written state equations for the building energy system. Okay. Let us go back here. What is it written? State space equation. So this is actually a block. Let me give you an introduction for Simulink also. This is your Simulink. This complete window which you are seeing where you are not writing any code is a Simulink. And if you want to develop something, for example, you want to develop a circuit or anything, it can be a thermal circuit, it can be an electrical circuit, it can be anything. You can develop it using the library browser. Okay. Acha, interestingly, again, when I want to tell you, 2 ways I could have done this. One way was I can draw this RC circuit which you are seeing on your screen for 1 wall. So cuboid, so 6 such walls, 6 such RC figures. It became very, I have a conference paper also, but now it was published in 2014. After 10 years, when I see, I crib about it, ki yaar, ye kaisa paper likha hai. It makes a very complex situation for one particular room. And I told you the assumption is that whatever study I am telling you is a single zonal study. It became almost next to impossible for that such complex circuit to multiplicate it and then work on a multi-zonal model, right? The easiest way was linear algebra, just this equation. So what I'm saying is this figure is nothing but equivalent to this mathematical model, which is equation 5. So it became very easier. So you may ask, sir, why in MATLAB we are only working on state space? Why not we are drawing this RC as you said? This is the reason. To reduce the complexity, this complete 3 resistance, 2 capacitance, I can completely represent it just by using one block, which is the state space block. Now, if you double click it, all these values, all these expressions, A, B, C, and D, is nothing but coming from these values: R1, R2, R2, C1, R2, C2, R2, R3. And what are these R1, C1, R2, R3? This. How did we get the value of R1, R2, R3, C1, C2? Oh, it is not there in this PPT. Through this. Total thermal resistance and total thermal capacitance, RTH, and CTH, I can get it from ASHRAE handbook. That is a wall, multi-layered walls, thermophysical properties, which are nothing but density, specific heat capacity, thickness, right? From there, I'll make it a fraction. What is the values of x1, x2, and y1, y2? This paper. This optimization algorithm will give me the values of x1, x2, x3, y1, y2. How it will give? It is an optimization algorithm, right? So based on that, I can get the values of R1, R2, R3, C1, C2 for particular total thermal resistance, total thermal capacitance. If you add these, you will get these RT and CT values. Okay. Now come back to this building energy model. So you can see here. So this is my complete model, which you can see. For window, I told you it will not be a single RC model. These again, we have taken, this is complete mathematical description of the equations. Actually, I am an ASHRAE member, but I don't know where I have saved the ASHRAE handbook. I just wanted to tell you that if you go to the website and you have this handbook online, it's a beautiful handbook. It has all the equations. You can code these equations in your, research papers also, right? So if you decode these equations as well, technical resources, handbook online, you can see that you will get a very good amount of all these equations. See, I told you, right, why I am doing this. This is a complex procedure. Yes, I'll tell you. But why we are doing it, this is because, again, this was coming from Dr. Ajay Mathur sir, who's right now DG for International Solar Alliance. But at that time, he was Director General of Bureau of Energy Efficiency. So I had a chance of meeting him because of my supervisor. So he said that everything we cannot depend upon the data. And this is what we discussed in the previous lecture also. Fundamentals of energy physics is important for us to understand. So that was one motivation. Second motivation was, when I don't have the money for hardware, I have to work very hard on the mathematics. So that means either I have to build an analytical model or a numerical model. So we built a numerical model based on the fundamentals of building energy physics. And where did we get the fundamentals of building energy physics? From this ASHRAE handbook. So this is the ASHRAE handbook of fundamentals. All these chapters, all this information you will get from here, from this ASHRAE handbook. All these equations, how you will get the relative humidity. Remember this equation. This is the equations that I have modeled taken from this ASHRAE handbook. So these are just textbook equations. How I have modeled? Just a second. It's not responding. These small blocks which you are seeing are function blocks. These are function blocks. So this is nothing but a logical operation. This is sun time, this is omega, equation, decibels, everything, right? So all this you can do it. Then of course, I told you, let us go here. So this is the building space model, building constructional model which we have taken. And what is the value of R1, R2, R3, C1? We have taken from this paper. How we have taken, I have explained you in detail. Let me further go ahead. Lost me the time. Now, this is the HVAC system model. This is the all seasonal HVAC system model again taken. Again, all these equations are there in the ASHRAE handbook. I encourage you to go through it. ASHRAE handbook of fundamentals अब उन्होंने रोक दिया है बनाना after I think 2018 or 19. So what they did is HVAC systems equipment they have started and HVAC applications. All those equations have come here in the HVAC system applications. This again is the new chapter that they have incorporated. That is a solar air conditioner systems. I'm trying to work on this. It's very hard to get, to be very honest, motivated research scholars right now to work on. This is actually multidisciplinary aspect, but it is very interesting. To work on the PV systems or a PV thermal systems or a PV recovery systems. So you can get through these ASHRAE handbook also. So we see that we are using PID controller. That is what is here. PID controller. That means this is the building space thermal energy balance equations, latent heat and moisture heat. You require a temperature sensor. Temperature sensor, I told you that it is a dynamic equation. So ordinary differential equation. तो जो output आता है इस equation से, that actually is not temperature but rate of change of temperature, dTT by dt. So I am using an integrator. This is called as an integrator. If you double click it, it is an integrator. When you integrate it, you will get the temperature. So I have given it a meaning of air temperature detector. Then it goes to the PID control. This is my PID. Simple. How to make this robust? How you will make robust? See, robustness means, I think I have a time. I'll just take some time and finish you. And this is my occupancy schedule model. This is very basic. That's why I have taken it as cyclic. I'm just telling you. All these blocks, if you double click it, you can change the properties. Right? How many hours per day? What is the start hour? What is the operating days? You can change them. How? You right click, go to mask parameters. Yeah. So here you can take all the block properties and you can then enter the text and what you want to do it. Right? So this, you are getting operating hours a day, start hour and operating hours. Just a second. Yeah. Operating hours per day, start hour, second property, third property, operating days per week. And you can keep on adding it or you can keep on deleting it, right? Depending upon your application. Okay. Now, let us go back here. So after this, what we have the heat exchanger properties, all of this. Filter, heating coil, cooling and dehumidifying coil, this heat exchanger. This heat exchanger is a third order lumped parameter hot water emitter model. There is a paper which was published in 2014 only by Professor C.P. Underwood. It is an excellent paper. If you go through it, it has all these equations. Ye heat exchanger equations I have not taken from ASHRAE, but taken from that particular book. Those equations are these. These equations, simple. 3 parameter model, 1 parameter, second parameter, third parameter. So 3 parameters, right? Now, in order to run this, before running it, let me show you that I have to give the data first, weather data. That weather data we have like an Excel file. So what we have to do first is, let me clear this. Always remember this file, simulating file should be in the same folder where the data Excel file is. Always remember this. Otherwise, it will show you the error and you will get confused. That Excel file, I have to right click, import data. Let us wait. A window will open where it will show the data and it will tell us, do you want it in terms of what you call Excel, table, structure. So this is the whole data. First is in seconds, right? That's why it is in seconds. Let me take table, import data. You can see the data has been imported. W data. That means this W data will work. Okay. 24 hours, 3600 seconds. I am employing this. So if you run it, it is compiling unsupported input data. Sorry, there is an error. Let us go here, not as a table, but a numeric matrix. Let us make it a numeric matrix. Import selection, run it again. Now it is running, no error. Now see here, it is showing me the energy calculation. 3.4 units of energy has been used. You're getting my point? So, this is set point and this is the ambient temperature or optimal temperature graphs. Just a second. Okay. Now, of course, because this is a PID controller, it will always be, it will never be constant. It will be around the average value. What I'm trying to say is, see here. Where is the temperature? See here, the temperature without control. This is nothing but which was in the paper is this. Okay. Now, if you want to do it for 7 days, for example, 5 days, no, 7 days. So into 7, run it. Let us wait. Let us see the results. Oh, it has been paused. Extremely sorry. See, now you are getting. Now, why the temperature is coming down for 7 days? Because in the occupancy schedule model, I told you that the occupancy will only be for 5 days, right? So this is how interestingly you can make it. And you can try to run the models. Now, the research that I'm majorly focusing upon is that this set point temperature will be in the control of grid distribution company. So it will not be a constant or an average value. So distribution, so there will be another model which will be much more complex that will be driving my PID controller. How to make PID controller robust? I'll show you. I told you we always develop controllers for transfer function models. That is Laplace transfer function models. Now, for example, the model you are seeing on your screen, it has, or let me show you this. R1, R2, R3, C1, C2. Now, please try to understand what I'm trying to tell you. Okay. My paper of 2016, 10 years back, says this will be the value of R1, 0.0724. This will be the value of R2, 2.9401. This will be the value of R3, C1, C2. And my PI controller is working for these values of R1, R2, R3, C1, and C2. Now listen to me very carefully. Robustness means that there is a chance that the value of R1 is not 0.0724, but it can be 0.777 or 1.01 or 0.06. Stochasticity, randomness. इसका मतलब ये है कि R1, R2, R3 की वैल्यू डिटर्मिनिस्टिक है बट एग्जैक्ट नहीं. देयर इज एन अनसर्टेनिटी अटैच्ड टू इट. क्या मेरा पीआई कंट्रोलर तब भी चलेगा? क्या मुझे तब भी वो वाले वैल्यूज मिलेंगे, दो ग्राफ्स मिलेंगे? दैट इज रोबस्ट कंट्रोल. सो आई हैव टू डेवलप, I have to tell MATLAB that the values of the parameters, their real values are 0.37, 0.3, 0.2, but they have a level or certain percentage of uncertainty, plus minus 90%, 90%, 90%, 90%. Usually we never take such high uncertainty, because if you are taking such high uncertainty, that means you are reduced order modeling or the paper is itself is wrong, right? But we take a level of uncertainty, for example, 10%. Then we develop the transfer function models using the Laplace domain, Laplace variable S. Then work on then see how, to what amount of margin of robustness can my controller handle. As a, for example, again coming back to that example of two-wheeler, कि आपने कंट्रोलर बनाया कि टू व्हीलर रोड पे चले, लेकिन रोड पे गड्ढे हैं, तो क्या आपका कंट्रोलर फेल हो जाए? गड्ढे झेलने लायक तक का कंट्रोलर है कि अगर गड्ढे बहुत ज्यादा और बहुत लंबे समय के लिए, दो तरीके के गड्ढे हो सकते हैं, लार्ज डिस्टर्बेंस, स्मॉल टाइम. बहुत लंबा गड्ढा बट छोटा, स्मॉल डिस्टर्बेंस फॉर अ लार्जर पीरियड ऑफ टाइम. छोटे 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 गड्ढे हैं बट पूरे रोड पे हैं लंबे समय के लिए, राइट? आपका कंट्रोलर जो आपने बनाया है अपने व्हीकल के लिए, अगर कोई ऐसा गड्ढा है जो बहुत लार्ज है और बहुत लंबे रोड के लिए, तो आपका या तो पैसेंजर सेफ नहीं है या तो फिर व्हीकल सेफ नहीं है, आपका कंट्रोलर नहीं कर पाएगा कुछ काम. तो वो मार्जिन कितना है? दैट इज योर रोबस्टनेस स्टेबिलिटी मार्जिन. बेस्ड ऑन इट यू डू द वर्स्ट केस परफॉर्मेंस एनालिसिस. मतलब यू से कि ओके, I understand that R1 value is not 0.0724. But what is the worst R1 value? So we will take the worst R1, worst R2, worst R3, worst C1, worst C2. For these worst values, we will develop the control. And we will say that if it is working for the worst case scenario, it will work for the best case scenario. That is nothing but your robustness. Simple. Nothing else. Okay. I hope that I have made myself clear. So these again are the same things that we discussed in previous classes, previous lecture. And I hope that I was able to provide you with, this is also important. This I think I have missed. Okay, this equation, objective equation, optimization. How do you model it? So there are three variables: temperature, illumination, CO2 concentration. Temperature as variable 1, illumination as variable 2, air quality, that is CO2 concentration, as variable 3. These are the real-time sensor readings that we are taking. This should be a series, but only for this purpose I have taken this. So this is the error calculation. What is this error calculation? This set point minus this into this. So this is the here delta T, delta L, delta C. This is what is happening. And these are the weights: lambda T, lambda L, lambda C. These are the weights. I have taken equal weights. You can change the weights. These are the empirical calculations, again taken from the ASHRAE handbook. Empirical means based on experimental data. So when I don't have the money for hardware, I can take some papers, research papers or handbooks, experimental data. Based on that, I developed a genetic algorithm PSO optimization technique. Every optimization technique has to have upper bound and lower bound. There are 3 parameters which I want to optimize. Hence, there are 3 lower bounds and 3 upper bounds. These are the GA and PSO parameter values which we have taken. As you can see here, GA PSO was used before as a code. Now it has toolboxes. So you can call them as toolboxes. It will be very easy for us to use them. So that's all. I hope I was able to provide you with relevant information and particular MATLAB based. I will not be able to share all the MATLAB codes, but I will be sharing the particular codes which were published in the paper or the literature. Thank you all. Thank you once again, Professor Meena sir and Professor Ravi sir, for giving me the opportunity to interact with you all. And thank you all the participants for a patient listening. I'm here to take up any questions if you have. Thank you, sir. Over to you.
Thank you, Harish sir. Participants, if you have any query or you want to any discussion, please ask the expert directly. Harish sir, I have a question.
Yes, sir.
Especially in the presence of varying occupancy and weather conditions, kind of, that is, how can PID controller be optimize the dynamic thermal load in the
Yes.
smart building?
Yes, there are 2 types of controllers, sir. One is online and one is offline controllers. What an online controller does is कि सेंसर से जो भी डाटा रियल टाइम में आता जा रहा है, PID कंट्रोलर उसको ऑटोमेटिकली इनपुट लेते हुए उसको काम करता रहता है, right? So we develop controllers, such controllers, where we have one thing that I did not discuss is where we have a time delay. So we make that every signal from one point to other point takes some time delay, and there is a medium through which that communication is happening. उसका भी एक ट्रांसफर फंक्शन एक ब्लॉक बनाते हैं सर. So PID controllers input also has certain amount of measurement and sensor loop. So we consider it as a sensor loop in our transfer function. If it is off, this is in condition for online, जहाँ पे डाटा आता जा रहा है सेंसर से, PID controller काम करे जा रहा है. Second is offline, where we accumulate the data, make it an Excel file, and then we import the Excel file to the MATLAB, and then MATLAB takes it from the workspace for that particular data.
Okay, sir. And sir, you talk about the national smart grids. Then what are the key challenges to integrate that building level control with the smart grid?
Sir, technically, I'll speak, sir, because there are some policy and regulatory challenges also. Distribution company करने नहीं देता, sir. Grid को छेड़ने नहीं देता. That is a regulatory challenge. Technical challenges are that when we go to the market and a consumer is much more confident on grid. Like for example, my confidence on Delhi BSES Rajdhani Private Limited is 100 times more than Tata Voltas. Right? So what we are trying to, or what I have shown in the previous 2 lectures is something that majorly will be owned by AC companies, air conditioner companies, that they will provide smart ACs, building to grid integrated ACs. I think that is one of the more technical challenge, that each and every state grid may have different frequency voltage regulations and different behavioral pattern. So our controller should be very much robust. A manufacturer who is installing a smart grid integrated AC in Delhi should be able to install the same air conditioner with certain different parameter changes in Mumbai also. So one is that technical challenge in terms of frequency and voltage to make the controller robust.
Thank you, sir, from my side. Participants, if you have any query, please ask the expert directly, or you can write in the chat box. I think there is no more questions. So now we conclude the sessions. So thank you all the participants for today's technical session. That is session on the control of buildings and energy control system led by Dr. VSKV Harish. And the session is covered, that is a key concept of smart building control, including the use of thermostatically controlled load, various controller types, and strategy to optimize the energy use while ensuring the occupant comforts. And Dr. highlighted the integration of controlled and uncontrolled parameters in the building models and their implementation in the energy efficiencies. A notable part of the session was on the hand-on demonstration using MATLAB, where participants PID and its application in dynamic building systems. And the discussion extend to creating a robust control strategies that is capable of adapting to the real-time building behavior and external conditions. And Dr. Harish also introduced the reference from the ASHRAE handbooks that is emphasizes the best practices and industry standards for HVAC and control systems, and linked these to a broader initiative such as the National Smart Grid Missions, and demonstrating how the building energy control system contribute to the smarter green and energy ecosystems. So we extend our sincere thanks to Dr. sharing his expertise with us and all the participants for their active engagements. And we hold this session add valuable to your future event and intelligent buildings design and controls. So thank you everyone, and thank you Dr. Harish.
Thank you, sir.
Now we close the meeting.
Next thing will be.
And the participant, the next session will be at 3 o'clock today. Please join us at 3 o'clock session of the FDP program.